This panel ruined my month. Well, more accurately, it was Yuto Suzuki's explanation the following week. How the fuck is this guy still alive? The character Atari explains this for us. The tunnel effect. It's a phenomenon in which a particle can penetrate a barrier greater than its own energy, even though the odds are infinitesimal. Holy fucking shit. The answer is fucking quantum mechanics. Now, this might sound insane to the average person, but I am not your average person, and I can tell you that this is so much worse than you realize. This last semester, I took a class called Physical Chemistry 2. This class was so fucked up, but to sum it up quickly, it's quantum mechanics for chem majors. But we're forgetting the most important part. I passed with a C. Before we get into the nightmare, there's some basic stuff I need to explain. Also, very little of it is going to make any logical sense. Essentially, quantum mechanics comes from our observations of quantum particles doing really weird shit, and then inventing math to explain the observed weirdness. The double slit experiment is the most famous example of this. From it, we get one of two concepts necessary to understand quantum mechanics. Wave-particle duality. Thankfully, this one's easy to understand. It just means that everything has the properties of both a wave and a particle. This includes you too. This is because of the de Broglie relation. Lambda equals h over p. TLDR, the more momentum something has, the more particle-like it becomes. Light has very little linear momentum, so it acts mostly like a wave, whereas a car has lots of linear momentum, so it behaves mostly like a particle. Energy quantization. Basically, energy isn't continuous, it comes in little bits. In effect, energy can only increase or decrease by a fixed value, that being the energy of an electron. Not too bad so far, right? But now it's time to talk about the Schrödinger equation. Yeah, that Schrödinger. Classical mechanics fails at the atomic scale, and in order to make a new equation of motion, we need the previously discussed concepts, quantized energy and wave-particle duality. The guy who was insane enough to figure this out was Erwin Schrödinger. He proposed the Schrödinger equation, very original, h hat psi equals E psi. Looks simple, right? Wrong! This shit is absolutely bonkers. Let's break down the terms. H hat is called the Hamiltonian. It's an operator corresponding to the total energy of that system. What's an operator? An operator carries out a mathematical operation on a given function. And in its full form, it looks like this. It spits out quantized energies. Next up in the insanity parade is the wave function psi. This adds the wave-particle duality. What does it represent? Well, it's kind of fucked up, because it's the solution to a differential equation that depends on the potential energy. What the fuck does this mean? Well, it means that the wave function changes form based on the potential energy function. That's it for the Schrödinger equation's hard terms, because psi is on both sides, and E just means energy. Now we can describe the motion of quantum particles with this monster of an equation.
Oh! Ew! Dude! What the fuck?
Horrific, right? Well, it's actually worse because this only covers one dimension. In 3 dimensions, the Hamiltonian actually looks like this.
Boy, ain't no fucking way, boy.
That's nice and all, but now we need to talk more about the wave function. the wave function. Truly the bane of my existence. But in order to keep making this video, I need to go more in depth. What the fuck even is a wave function? Well, it's a function that describes the quantum state of a particle. In effect, it contains information like momentum and position. Even now, there's still some more stuff to cover before we can solve for the probability of Shin surviving. We'll be using the Born interpretation of the wave function. Don't worry too much about the specifics here. What this gives us is that the square of the wave function gives us the probability density. What's that? It's the probability of finding a particle within a given space. This is the equation. Psi star represents the complex conjugate of psi. What does that mean? Don't worry about it. I really don't want to explain complex numbers right now. In 3 dimensions, the probability of finding a particle in an infinitesimal volume at a point r is proportional to this. Finally, we have what we need to figure out how Shin didn't die. Oh yeah, it's quantum tunneling time. So when a particle of mass m and energy E hits a potential barrier of height v and width L, classically the particle can't get past the barrier, but because of quantum fuckery, it can tunnel through. This happens because the math says it can. In a quantum tunneling scenario like we see in Sakamoto days, the shape of the potential divides the space into 3 regions, left, middle, and right. In each of these regions, the potential is flat. Given this, the most promising functional forms of the wave function are e to the power of ikx and e to the power of kx. Now onto the wave functions of the different regions.
Money isn't real. Gold isn't real. Banks aren't real. You know what's real?
The middle wave function. This represents the particle when it's within the barrier. Here, v is greater than e, so e to the power of negative kappa x and e to the power of kappa x work the best. Next up, we have the Schrödinger equation for the middle. Only 2 more to go. Fuck it, intermission time. There's been too much math. I'm gonna talk about the story right before the quantum bullshit. So Shin and gang are on top of the Tokyo Skytree for plot reasons, and they're trying to hijack the radio frequencies. This is immediately interrupted by Uzuki off a fucking perk flying an F-16 into the spire of the tower. This buries gang under rubble. Very sad. Uh-oh, Uzuki is alive and a fight ensues. Shin gets bailed out by the weapons hacker Twink guy when he shuts off all the guns in Japan. Long story. No gun, no problem, because Uzuki has a chain sword whip thing. He ore farms some more until Shin finds the seat to the fighter jet in the rubble. What does Shin do in this situation? Is it A, continue to hold off Uzuki until backup can arrive? Is it B, run the fuck away? Or is it C, use the ejection seat to launch them both off the Skytree? Well, this manga's insane, so of course the correct answer is C. They fall for a while until they end up landing in the massive fish tank of an aquarium. This manages to trigger a memory within Uzuki of Ryan Akao, stunning him temporarily. Shit, a shark attacked Uzuki and brought out Takamura. Shin is beyond fucked right now. His future sight is just barely enough to keep him alive right now, and he's reaching his limit. Escaping into a different tank only buys him a few seconds as the aura farmer immediately finds him. Takamura is fully in control of Uzuki at this point and is attacking any source of bloodlust around him. This unfortunately includes all of Uzuki's men who are trying to help him. Using this bit of downtime, Shin rushes into a tunnel. And now the tone goes from frantic fight for survival to downright survival horror. Uzuki has found him. As he breaks through the ceiling, Shin only has one chance. He needs to freeze Uzuki with his ESP or he dies. Shin fails. And now we're at the point where I have to explain more math. Thankfully for us, the left and right Schrödinger equations act the same. The Schrödinger equation for both of them is this. The wave functions must be continuous and smooth for tunneling to occur. How do we determine this? Why, with boundary conditions, of course. For the left side, it's continuous and smooth if these equations are satisfied, and for the right side, it's continuous and smooth if these equations are satisfied. Additionally, we know K and kappa because of these equations. Leaving out a shit ton of algebra, we find the ratio of transmission. Now, with all those equations out of the way, we find that for a high wide barrier, the transmission probability decreases exponentially with the thickness of the barrier, the square root of the particle mass, and the square root of the energy deficit. That was a lot. But now we can get to actually discussing quantum tunneling in the context of Sakamoto days. It's calculation time. To start off, I'm going to do a test calculation using a single iron atom. We have a mass of 9.27 times 10 to the negative 26 kilograms, a potential barrier height of 1.602 times 10 to the negative 9 joules, a width of 0.38 meters, and we assume the energy of the iron atom to be 1.41 times 10 to the negative 12 joules. The equation I'll be using is the WKB approximation. Here it is in all of its horror. Just kidding. There's an approximation of the approximation that you can use when the transmission coefficient is a lot smaller than 1. And yeah, it's going to be a lot smaller than 1. Plugging in the numbers, we end up with t equals 10 to the negative 5.39 times 10 to the 16. Whoa. This number is so fucked up, we need a reference. To Wikipedia we go. Okay, time to find out how fucked up this number is. Oh shit, that's the monkeys typing Hamlet. 10 to the, it's not even close. Big magnitudes, just to see if there's something equivalent. It's beyond computing. It greatly exceeds what is needed to describe all known physical limitations within the observable universe, or precisions better than Planck units. That's just the test calculation. Anyways, in order to properly estimate the odds, we need to estimate the number of atoms in the sword that interact with Shin's neck. Shin's neck is 38 centimeters wide, and we assume the blade to be 0.7 centimeters thick and 2.25 centimeters wide. This works out to 59.85 cubic centimeters of sword. Assuming a 2% presence of carbon and a 98% presence of iron, the density works out to 7.76 grams per cubic centimeter. With this, we find that the sword's mass that interacts with Shin to be 464.44 grams, 455.15 grams of iron, and 9.29 grams of carbon. I think it's time for a calculation speed round.
Bing, bop, boom, 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 bop, bam. The type of shit I'm on you wouldn't understand.
With that out of the way, to find the final probability of the sword tunneling, we find the probability of all the iron tunneling and the probability of all the carbon tunneling, and then we multiply them together. For the probability of all the carbon atoms tunneling, we take the probability of one carbon atom tunneling and multiply it by itself this many times. This comes out to a chance of 10 to the negative 8.07 times 10 to the 38. Doing this with iron yields a chance of 10 to the negative 2.65 times 10 to the 41. Multiplying these two together, we get the final result. The probability of Shin not dying to Uzuki cutting his head off is 10 to the negative 2.66 times 10 to the 41. To put that into a more comprehensible form, 10 to the x, it works out to approximately 10 to the negative tredecillion. This number is so stupid. But you want to know something funny? In reality, it's probably actually even smaller than this. This was a rough estimate, and I don't have a fucking PhD in quantum physics, so I don't think I can do better, but like now that I have the number, I can talk about the consequences. Hi, I have a camera now, so you know what that means. It's Unhinged Rant time. Okay, can you guess the number of particles in the observable universe? It's 10 to the 82. That is so much smaller than tredecillion. It's absolutely absurd. Like, the degree to this smallness is incomprehensible. The smallest reference on Wikipedia was 10 to the negative 300 something thousand. That, it's just orders of magnitude greater than anything I could find. And it's just insane, because it means that I, as an individual, have ruined Sakamoto Days power scaling. Sorry, not sorry. I think power scaling's a little stupid most of the time, especially chain scaling. Good example of this? Fucking Dipper Pines. Do you know what the Versus Battle Wiki states as his speed? Fucking relativistic. Incomprehensible bullshit. I mean, I know how they got to that. I think their methodology is stupid, but the things that you can do with 10 to the negative tredecillion is absurd. Okay, thought experiment time. I'm Atari, my fucking phone is Goku. The odds that me doing this causes like some fucking aortic dissection, just instant death horror type shit. The odds of that are most definitely significantly greater than 10 to the negative tredecillion. The interpretations that you can go to with the fucking luck manipulation is too much, but I kind of love it. Because you want to know the crazy thing? The math checks out. I've double, triple, quadruple checked this bullshit because I've spent 10 months making this video. And yeah, it just works. It's fucked up. Anyway, I don't know if I'll ever make a video like this ever again. If you have suggestions, please give them to me. I am crazy enough to do this. I will do other things. But ultimately right now, I just kind of want to make videos about the things that interest me, which could be literally anything. So like, subscribe, and comment if you want to see what comes out of my crazy fucked up brain. Because I'm probably either gonna make a video on 100%ing Rift of the Necrodancer, insane rhythm game, or fucking, I gotta go grab it, my fucking beloved series, Kagurabachi. Fucking zoom in properly. This shit is so good, I need to talk about it. If you ever wanted to read like JJK or like Bleach, but like had some like real themes in writing, this is it. This shit is so fucking good. Anyway, I'm gonna end it things there because I've been yapping for too long. And yeah, I'll see you in the next one.